With the electrical side, we've got some construction over here where we're gonna pour a base and set up that vapor recovery tower. So those are the main things to watch for. Remember that while you're looking around, you kind of lose track of what you're doing, and that's what your hard hat's for. So be cautious of what things are above you and around you. Don't get bumped that way. The prairie dogs are safe. If anybody gets bit, let me know. It's too early for snakes. Rabbits are out, coyotes, but haven't seen any snakes. Okay, anything else you want to say before we start?
I would like to wait a little bit for everyone to sign first before
Okay.
we go to it. What do we do?
How many do we have? Aria?
38.
38? Sounds like 19 apiece.
So, okay. First row, go with me. Second row.
Not yet.
Okay, and then you and everyone on this side, go with me. Okay?
When we leave, not yet.
Not yet, not yet. We wait until everyone signs. Rise and stand up, sheet.
Sign it. It's right here. Okay. So, by the way, everything you see out here is donated. All the models, there's a big long model of a wellbore that was given to us by Chevron. They had a pump shop put it together. It's very similar to the one in their yard that they had, maybe you saw when you were sophomores, except ours is better. It's up off the ground. We've got the actual pump components in it that they used, just maybe some pipe to simulate when they did theirs. So that was real helpful. The models of the vessels came from Pioneer. Pioneer had these built, and the company that built them is Smith Industries out of Odessa. Smith found out that Pioneer was donating them to Tech, gave Pioneer a good price on them, so both those companies kind of went together to give us those vessels. Most of the vessels on the battery were donated by Pioneer, Apache, Chesapeake, Weatherford. So remember that when you're out on your job, you see stuff laying around, like, Tech can use that, send it back. Okay?
Mr. Gulam, do you want to talk about the going up on the tanks?
Okay, we can go up on the tanks. There's what we really want you to look at up there is the top of configuration of piping and the thief hatches. So I think if we go up there 4 at a time, everybody can have a thief hatch to look at, can open it, see how it works, and look at the inside. So let's go 4 at a time up there, plus an instructor. And then we'll just have to rotate up and down. You shouldn't take too long to do that.
Don't fall down, okay?
Remember the deal, you get one hand on the guardrail all the time, remember that?
First group, the group that go with me will do the tour inside first, okay? And we wait until it's a little bit warmer and then we go outside. Everyone sign? Who have not signed the sheet yet? Okay, Arya count the number of signature and number of students, okay? Okay, let's go, we can do it.
Okay, let's get the outside group out of the way first, okay? Back row and a half first, let's go with me.
Okay, group 1. Do you need
I'm taking my group out first.
Okay, you take your group out first. Do you need a PA system?
No.
Not yet?
No.
Maybe in the afternoon?
Yeah. Everybody got a hat, glasses? Please. Take a deep breath.
Okay, group 1. Let's go to the well. Let's go take a look at the well. will start from the perforation. Come closer, come closer. You cannot see anything if you don't come closer. We start from the perforation. Quick question from me. What's your name?
Clara.
Claire, what is this hole?
Those are the perforations.
Perforation, very good. Okay, we have gas and liquid going up. Then we have, what's it, tubing anchor? Gas go through this way and liquid can go inside to the, the next one is, you see this part? It can move up, down. So, next person, what's your name? Derek, what's this? What's this?
The rod.
A rod, yes. We just come it up. This is covered in other class already, right? And this is what? Cement. This is a tubing. So we take everything up and okay. Casing valve, and the fluid go up here. Some fluid go in the annulus, right? And some go in the tubing. So the one that go in the tubing is mainly liquid. We separate it out already. And then we try to pump it. Typically, we have them connect to each other, even though we separate already, but to reduce the number of pipe. Otherwise, we need two pipes, one from the tubing and one from the casing to go to the main battery, right? So you can see here that they are connected. See, flow this way, connect, and go out. Good. We have back pressure regulator or back pressure valve. If we screw in more, we cannot flow much. So this is to control the pressure this side. We have a stuffing box. Look at the stuffing box, and you can see. Come one by one. Take a look at this. We have many sealing, you see. So this is for kind of high pressure. Okay, after you look at it, walk out and next. Come in. Take a look at this. Because this is not the same as outside. So this one is for like high pressure. See how many do we have?
6.
And oh, by the way, for the like field trip today, we don't have any homework exam or anything, but what you will do is put all this in your project. Okay, so in the project you should talk about safety. Okay, and you don't need to draw the diagram on how fluid flow. So it starts from the well and then go to where. You don't need to do that drawing, but it will appear in your project. Okay, senior design you will have that. So I hope for the rod pump, with the rod pump, you connect them together and then flow to the facility. Which class that you study about this? Which class? Production. So we kind of go over it briefly. All right? No question. Of course. Okay, and you have seen this already? Yes.
No.
Okay. No?
No, this wasn't there.
Oh, it was not here?
Yeah, this was here.
So from the wellhead, for this well mainly produce oil, okay, liquid. When it mainly produce liquid, we don't need line heater. No line heater for the rod pump well, okay? But for the case that it's a gas well, it will go to line heater. So the first component, let's talk about line heater. Oh, do we have it here? No, maybe we don't have it here. Okay, the first, so after the rod pump, it go to the separator. What's your name?
Benedict.
Benedict. Where is the separator? Can you show us, please? Go. Which one separator? Okay, can you open inside? Okay, we can open this part. Alright, this is separator too. It's a free water knockout. What else is separator? Is this one separator? It's not, this is just a model. The real one is outside. Okay, the real one is, if you stand on the real one, it's just this tall. Okay, the real one is a lot taller. So this is a vertical separator. All right, Benedict. What about this one? It has this bio box. So this one is not quite separated, right? Okay. So next, what's your name?
Mobile.
Mobile. What is this one? What's this one? Yeah, just hit the trigger, right? Okay. For well that produce mainly liquid, first step is go to separator. Okay, we want to separate gas out. There's a little of gas, and we take it out first, and then we can do free water knockout later. Free water knockout is a horizontal separator, and mainly occupy the water. There's a little gap on the top for gas. Let's take a look at the first separator. So vertical separator, this one is a low pressure. Okay. Question. What's your name? Mackenzie. What's your last name? Reese. But I never Mackenzie is not here. Oh, yours name. Okay. Mackenzie Reese. What is the pressure rating of this vessel? How much? How do you know it?
125.
Is that the working pressure? WP, right? Is it? Okay. What about the test pressure? It was tested at what? How much?
It's 30 by 10.
30.
Sorry.
It said 30 by 10, right? So sometimes they didn't put the test pressure, but this should be test pressure.
Give me.
How about you? Did you answer anything? You did. Mackenzie. Thompson. Where's the inlet? Where's the inlet? You can open inside. Where's the inlet?
Okay.
This one? Okay, let me give you a hint. Mackenzie. When fluid come in, the first component that it hits is inlet diverter, right?
Yes.
Can you locate inlet diverter?
Right there.
This one is a baffle, not the inlet diverter. The purpose of this is we will have a float, like a spherical shape that float on top of the liquid, right? So if we splash something on the float directly, the float moves. So we need a plate, this baffle, to prevent any direct hitting of the fluid. Otherwise, when fluid come in, it hit the float just moves. We don't want that. We want the float to move according to the fluid level. So, what about this one? Is that inlet diverter?
Oh yeah.
Okay, so where's the inlet? Alright, thank you, Mackenzie. Correct. Next, Benedict did it already. Okay, what's your name? Brandon, come here. What about this one? Let me give you some hint. What do you see when you look inside? You see something?
Like mesh.
Mesh. Okay, so this has to be
The mist extractor.
mesh extractor is a mesh, and this is the outlet of
Gas.
gas. What's your name again?
Brandon.
Brandon? Thank you. What about this one, Brandon? Can you help me more? What?
Release valve.
Pressure relief valve. Very good. I think you should stay here. You can answer everything so we can go quicker. So this is a pressure relief valve. If you look inside, what do you see, Brandon?
Inside the separator.
You don't see anything, right? It's go all the way inside, right? So this means any pressure that build up inside, it can communicate. Oh, where's my finger? It can see the pressure relief valve. And where's the side glass, Brandon? Oh, you want to change?
What?
You want the next person yet?
Sure.
Okay. So next, what's your name?
Elena.
Alina? What's last name?
Carter.
That's two Alina, right? Okay. Alina Carter.
Yes.
Where's the side glass?
Here.
Yes, and we have another one.
Right there.
All right. What about this one? Is that the place for we go inside to clean it?
Right here?
Yeah, this one.
Yeah.
So what's that? Manway?
Manway, yeah.
Manway. So, and we have the stair outside. On outside, the real model, we also have stair. Don't climb. This one don't go up. Okay. What else should I ask you? What about that?
Is that the inlet?
Oh, that's the inlet. Where's the oil outlet? Where's the oil outlet? Or liquid outlet?
This is the oil outlet? Or this one?
One of them, right?
Yeah.
Yeah, it has to be one of them. It's okay that you cannot tell because it's just one of these. What about, why do we have two?
One for oil, one for water.
Yesterday I thought it like that too. So when I asked Mr. Bula, he said, no, we put the dump valve. So the dump valve is on the bottom, and on the top we put the float. Dump valve and the float, they connect to each other. So when the float move, dump valve move. And they are over there. Where is it? Oh, we don't have the model for the float. So this is the dump valve for the separator. See this one? So it connects with the float. The float you will see outside. When this thing move, the top part move, this thing move too. Okay, to open and close. So we don't need someone to just stay there and open and close the valve. After the gas part go on the top, right? Oh, you can go back, or you can stay here. After the gas part, we have something to control the pressure. And can you help me? Okay. Did you answer anything? What about you?
No.
So after the gas valve, we should put some kind of regulator. What do you think, Daddy?
The gas pressure regulator.
Yes, correct.
To regulate the pressure going down.
It's a back pressure regulator. We don't put back pressure regulator on the oil side. And when we go outside, we will see that sometimes they call it Kimray valve. But all this, that's Kimray, and that's Kimray. Okay? But if they just have Kimray. So, and this is a dump valve, and this is a dump valve. So this is a dump valve for separator. This is a dump valve for a heater treater. The difference is this one connect with the float, but this one is just a level that can overcome this mass. So when I open and close this, the valve open and close. Last year field trip, there's a recommendation that once in a while, they should go open this, like every day. Do this every day. So that is to prevent if this thing gets stuck. Just that. Okay. Pressure regulator inside. If I screw this more, you studied this from production method already, did you? One of you. What's your name?
Taylor.
Taylor, come here. What's inside this? Oh, you didn't do it in production, right?
Not that I can remember.
Okay. So when we screw this in, we change what?
The cross-section area that the fluid can flow through.
Not quite cross-section area, but inside there's a spring. There's a spring inside, and the model I think is over there. So Taylor, let's go take a look. So the spring inside, it looks something like this, okay? But that one is small one. So inside there's a diaphragm, and this thing has a diaphragm, and on top there's a spring. So when we squeeze it more, so this means gas need to have higher pressure to overcome the spring force, right? So we screw it down more, so this means we try to hold more pressure in the vessel. Make sense? So when it hit against the, oh, it's too far. Let me move that too. When it hit against the diaphragm, oh, you can say about that. When it hit against the diaphragm, if it doesn't have enough force, it cannot come out. Okay? So that's a back pressure thing. Back pressure valve. Typically it is this one, back pressure valve. So there's an inlet and outlet, and when we can overcome the spring force, then it can coming out. Next. What's your name, sir?
Levi?
Levi. Why do we not want to choke or screw it in too much? Why should not we have, we try to have as low as possible for the pressure inside the vessel? What's that?
We try to have, you said we try to have the pressure.
Minimum possible pressure in the first separator.
If you choke it, the pressure's gonna go up.
Of course. Why we don't want that?
Because it has a pressure limit and you don't wanna exceed it.
That's correct, but that may not be the main reason. Does it do anything with the well?
More back pressure on the well.
More back pressure on the well. And if you recall IPR curve, if we have a lot of pressure to overcome, we cannot produce much. What's your name?
Jeremy?
Okay, Jeremy, you don't have to answer anything until everyone answers, okay. So we have a lot of back pressure. That's not good for the well. So we try to have lowest possible back pressure on the vessel. Make sense to you? Okay. After this, gas will go to cell pipeline, middle run. And liquid will go to, in the liquid, we can still have oil and water. So that's oil and water. What's your name?
Matthew.
Matthew, where do you think it go?
Where does what go? Up?
Liquid part after the separator.
Either to the two-phase separator.
We have to separate it. Yes.
Yes, or yeah, then, yeah.
Where will that liquid go?
I don't know.
Free water knockout or heater treater or any of that?
One of them, yeah.
Okay. One point that I would like to emphasize is when we see all this equipment, it doesn't mean that you put all of them in your design. No, we put as needed. If we don't need, we don't put it in. For example, you don't have emulsion and free water knockout may be able to do the job. You don't need a heater treater. Or if you don't have much water, but it's emulsion, you may skip the free water knockout and do just the heater treater. Okay? But if we have a lot of water, a lot of oil, and have emulsion, we want to go through the free water knockout first.
So you said a lot of emulsion, free water.
If we have emulsion, oil, water, let's go to free water knockout first. The reason is we heat emulsion so that the oil viscosity go down. It's become lighter. And any entrapment of liquid bubble or, no, not bubble, water droplet can come out easily. We don't want to spend a lot of energy to heat water. Make sense? You like it better? So we knock the water out first. So let's go take a look at free water knockout. Free water knockout is behind you. Okay. You didn't answer anything. You did? Oh, you haven't. What's your name?
Emma.
Emma. Where's the inlet? Or do you see the inlet diverter? Inlet diverter. Look inside to see inlet diverter. Can you locate the inlet diverter?
Okay.
I think that look like oil bucket. That's liquid oil. Okay. So this is. What is this for? Okay, do you see inlet diverter when you look from this side? Does it have anything to splash on?
Yes.
Yes. So here's the inlet. To look at inlet, you look at the inlet diverter. Of course, this one you can see the internal part, but outside you cannot see the internal part. Next, you answer already? Hey, you come here. For the inside, for this model, we can see the internal part, right? But out, did you see the inlet diverter? Go take a look.
Yes.
That's the inlet diverter. Oh, you answered something already.
Yeah, I did.
Oh, I'm sorry. Okay, next. Next. What's your name? How many? For the outside unit, how do we tell where is the location of the inlet? How do we know that?
I guess you could follow the lines.
Follow the line, just that. Very easy, right? How do we know the gas outlet? We just follow the line, right? And gas should go to. Do we have gas tank?
Do we?
I'm asking you. Can you help me?
Um,
So oil go to oil tank. What about gas? Does it go to gas tank?
no.
How do you store gas?
So,
You sell it. You don't store it. If you ever put gas tank in your project, that's like, I really fail. Okay. So gas go to sell point. And we have, so gas come out from the top, right? Oh, thank you, Harmony. What? So this thing can act as a three-phase separator. It can remove pure water from the bottom, and it can remove just oil. Okay. So next, who's next? Did you answer anything yet?
No.
What's your name, sir?
Jared?
Jared?
Yeah.
Where's the oil outlet? And where's the water outlet? Look from the inside.
Being those two?
Oh, you know it, right?
You what?
You know it already. So where's the water outlet?
Oh. Say water be down here, oil up here? Or your,
Is that because
your valves, your float valves and dump valves?
is that because you know it already from your internship or something?
Yeah, well, water's on the bottom. oil's
Oh,
on
okay,
top.
very good. I'm a very good teacher, you see. Okay, we have side glass, this part, this and that. And on the top, we can put the temperature probe, pressure probe, or pressure gauge. And on this side, we have two holes again. So one can be for the float, another one is for the dump valve. We may have test separator in addition to regular separator. Even though the first step from the well is to go to the separator, right? We have two kind of separator. One is a test separator. Another one is actual separator. Test separator is just to test one well at a time, and the actual separator is a lot bigger. When we have to go into the test separator, what do we get? What's your name?
Landon?
Landon, what do we get after with the test separator?
We shoot a three-phase.
Do we know the flow rate of each? Or how many barrels we produce for each gas, oil? Do we know that?
Measure coming in to the test separator.
Okay. Test separator, the difference between test separator and regular one is that test separator has meter. The regular one doesn't have. And when you go outside, you see that. Okay. Next, what's your name?
Eric.
Eric, what is the pressure rating of this pre-water knockout? Come on.
125.
That's the working pressure, right? Okay. And they didn't put the test pressure in, but that's 6 by 15, that's just the size. And, okay, that's it. Question on this? No question.
I do. So, why would you spend the money on having a test separator and a regular separator if you can just put the meter on the regular separator and just turn the meters on and off whenever you want to test?
Okay.
Cheaper?
If I have one well, how do I know the gas flow rate, oil flow rate, and water flow rate of that one well. I just put it in separator, right? But what if I have two wells? What will it be?
Oh, so you have to be able to divert it.
Yeah, one of it has to do the test separator. What if I have 30 wells? So this means 29 go to regular separator and just one go to the test separator, and we can just test it for whole day. Then we know how many barrels per day that we get for oil, how many barrels per day that we get for water. So we can have, we don't need to have a lot of separator, but in general, you don't build the tank battery if we have just one well, right? So when we have 30 well, we build a tank battery and we test one well at a time. So we can see which well has the problem. So on January, it produced maybe 200 barrels, but February, it become less. So we know that that well has a problem. Make sense? Next, after the pre-water knockout, let's take a look at the heater trigger. It's over there. Okay, next person who haven't answered anything yet. Come here, what's your name?
Rohan.
Rohan. Where's the firebox? In class, we try to select the firebox rating, right? Where's that firebox?
Is it this?
Where's the flame? We will have actual fire inside the vessel. Okay. If you want to look at the fire in the vessel, where do we look at? Yes, the black part. And I think there's a good reason to make it black. So if it burns, it have something deposit outside, so we cannot tell. So it looks nice. All right, we look at this. If you have some cover or something, you will see a fire. But not in this unit, okay?
Yeah.
This is the back one. So inside there's a fire to look like the green thing. See?
Yeah, that's the
So-
firebox.
What do you want to come in contact with this heating limit? Do you want oil to touch it, or you want water to touch it, or it doesn't matter?
I mean, we definitely don't want oil touching it unless you want an explosion, I think.
Okay, good question, a good answer. So we want to maintain the water level to be above this. Okay.
Question. What is this?
What's that?
What is this for?
What's that for? Okay. That's for half. Oh, what is that? Is that a splash plate? These two separate your oil out. I didn't ask Danny yesterday. I will ask him, but I think this part prevent any direct combination. Like, what's this for? This part we have to weld all around. Okay.
Is that the splash plate?
Guys?
Not quite. Where's the inlet, Rohan? Or you want to change to the next person?
I mean, yeah, let's go to the next person.
Okay, next. Who's next? Everyone did it? Yes, everyone did it. The next one, maybe you can what's your name? Eric. Eric, where's the inlet? Inlet will have kind of inlet diverter. Okay. Where do you think is inlet? Is somewhat difficult. How about outlet? Outlet. Gas outlet. Where's the gas outlet? Do you see the mist extractor? Any mist extractor?
I don't see it.
What about this thing? You see mist extractor? Yes, it's inside. So that must be gas outlet. Thank you. Okay, next person. You want to do it? Kim Boy?
Sure.
Where do I put the pressure relief valve?
Up at the top,
Which one?
that little tiny one.
This one? Very good. Okay, next. What's your name?
Jordan.
Jordan? Where is the oil outlet or water outlet? Tell me
Water
one.
outlet? Probably be that bottom one.
Which one? This is a man way. This is a man way.
There's an outlet on the bottom. There's a fitting down there.
This one is water.
No, the fitting all the way down at the bottom.
That?
Yeah.
I don't quite agree. But thank you very much. Okay. When we have everything coming in, you can see the tube. You see this tube? The pipe inside? This pipe inside? Everyone see it? So when we have emulsion coming in from this side, everything go down to the pipe. Okay, everything go down to the pipe. All emulsion go down to the pipe. And when it reaches the bottom part, it has the outlet of that pipe here. So here will be existing water layer, right? So emulsion will float up, but it doesn't contact to this heating element all the time. This pipe will heat water, and heat from water will be used to heat emulsion to make emulsion become hotter. When emulsion becomes hotter, viscosity of oil drop and water can fall down, coming out. Okay, and then we take water out. You see this line? This line, when it go up, it a little strange. It have this part. Okay, so this is water go up, and this part is the pipe-in-pipe configuration. We can adjust. It's like a weir height, whether the internal part move up a little bit or down. Okay, then water go down again. So this way of doing it, this means we put some kind of head pressure or hydrostatic head on this side, and we can, so water go from the internal part, right? And then it's splashed over. Inside here, we can adjust how tall should be the internal part. So this means we control the water height. Okay? When we control the water height, this means we also control the oil-water interface inside. So if it is pure water, so water level inside and water level outside, they will be the same. But because inside has some oil, right? So the level inside will be a little bit taller, okay? And so by adjusting this, we can specify where do we want to be the oil level. Good?
Question. I'm still confused as to where the outlets are for oil and water in this.
I just talked about outlet of water, not oil yet.
Okay.
So this part is the outlet of oil. Outlet of oil and water, we will go outside and take a look at it to be precise. And we have several holes here, see? And when you go outside, you will tell me again, oh no, that's not what, when we go outside, you will tell me, where is it? Good? Is it in here? Oh, back pressure treat valve. Oh, from the diagram, I have outlet from the side somewhere here, and go to treater valve, and gas from the top go to back pressure regulator. So on the side and this side that have this thing is for water. So could be, oh, this one. We have this and that. Oh, I think I know what it is. So this part is the oil outlet. Okay. This part is the inlet for sure. So in the actual thing, we weld this all the way. So there is no leak between emulsion. Like emulsion cannot go in this section where it is just oil. So this section will be just oil. And we control the layer level of oil water interface by this adjustment. Equalizer. You see small tube in here? There's a there's small pipe over here. So this part, and there's a equalizer from, you see this connection? There's a connection between this and inside. So this is to make, what, okay, next. You, right? What is this for? What's your name?
Clara.
Claire, what's this for? Make the pressure where and where to be the same.
To regulate the pressure to.
No. I'm not talking about this adjustment. This thing. It have a pipe inside, right? And
Yeah.
it connect.
To the gas.
You can see it, right? It connects to the open area inside. So this makes the pressure on the head part equal to the pressure in this. Why do we need that? Let's assume if we don't have it, what happens?
Would it explode?
No, it doesn't explode. How much pressure do we need in the water leg to be the same as the pressure inside the tank? It will be a lot more, isn't it? Because it's not just has to be equal to the hydrostatic head in here, but it also have to be enough to compete with the gas pressure inside. This equalizer is to have liquid level just to overcome the liquid level, but not the gas pressure inside. So it doesn't matter how much gas pressure we have in here, that pressure will go here too. So the level over here just to compete against the liquid level inside so that we can adjust it. Question. And I think we have this one too. So this part is to make pressure the same between this part and this part, down bottom. Okay? But we need a little bit of pipe so that emulsion doesn't go in here. So this space is for the liquid that we already treated. I remember in the lecture, there will be some kind of display to prevent some kind of short circuit. You don't want emulsion to directly move up. You want it to stay on the area that is hot. In this vessel, the bottom part will be hotter than the top part. And if we touch the side, the part that is like, actually you can touch it. On the actual field, the side that is warm, that's where we have liquid. And the side that is not that warm, then that's where we have gas. Good? Okay, next unit will be, what do we do next? Any suggestions? Tank. We don't have oil tank in here, but we have the last stage of separate. So liquid from this heater trigger will go to this thing. What's the name of this? You want to help me? Okay, second time for you. What's the name of this? It is a tank, but it has some kind of name.
Storage container?
It has something to do with gun. Gun barrel. Yes, it has something to do with gun. Something wrong? Oh, okay. I open it. They call this gun barrel, so it is just a separator. What's your name? Mobile. You said gun barrel, right? Okay, let's move next. What's your name? What? Derek. Derek. What is the pressure rating on gun barrel? How many psi? How many ohms? Working pressure.
Oh, design pressure. Oh, 16 ounces.
16, just 1 pound. Derek, what about pressure rating on that? Heater treater. How much? Oh, yes. Please.
PSI, the working pressure or the testing?
How much?
The testing pressure or the working pressure?
Working pressure, WP.
75 PSI.
75 psi. What about this one? I want to change. We can do it.
125 PSI.
125. What about that one? We want to know how. 125 too? So this is 125, and the heater treater is 75. So if you want water, please go take it, okay? And after we finish, we will have restroom break or something. 75, right? So by looking at the pressure, we can tell which one comes first. Make sense? Yeah. We can tell which one comes first. So gun barrel is just 16 ounce. Almost no pressure. If we have more than 1 pound, this will explode.
Boom.
Okay? We don't want that. Okay, on the gun barrel, inside, the next, second time, right? What's your name?
Emma.
Emma, do you see something, Emma? What was that? Is that kind of inlet diverter? Yes. So the purpose of gun barrel is for who teach you about gun barrel? So Watson tell you what about gun barrel? Purpose of this? Oh, he didn't tell. He tells something. Oh, okay. You don't want to say. Gun barrel is the place where we have a lot of retention time. Retention time means how long that liquid will stay inside. Everything comes from the top, hit with the spreader plate, so it spread out, okay? And it stays inside for a while. A while means can be 6 hours, okay? So this is to give enough time if we still have some emulsion that really doesn't separate from that heater treater, or if we want to do very good separation. So with the gun barrel, it have a lot of retention time. It's like fluid stay inside very long, liquid will come out. Water will come out completely. And as you see, the pressure rating is just 1 pound, 16 ounce. It doesn't separate gas. But we still have some gas. Gas from the top will go to vapor recovery unit. Okay, gas from the top will go to vapor recovery unit. And the reason that we need that plate is to not have a short circuit. If it just come here and go to the outlet, that's bad. And when you go to oxy-field trip, you will see this again. And you will see this U-tube a lot with the adjustable via this part. So when you see something like this, go up, go down, it's for, what's your name? Did you do anything here? Benedict? What is this? Outlet or inlet?
Okay.
Of?
Water.
Because it comes from the bottom. Water has higher density, so it comes from the bottom. And oil will from, I think this is for oil. Okay. And we can tell, so next from Benedict. Did you do it yet? What's your name? Second time? Matthew? Where's the side glass?
What?
Side glass to see the level.
Oh, okay.
Do you have any? Is it over here? Is it over here? No. Someone take it out or we don't have it?
I don't see it.
We don't have it. Okay? So we don't have side glass. How do we know the liquid level?
I'm not too sure, honestly.
How about we open the tip hat? This is from the top. We open this part and we put some tape in.
Yeah.
Color card will tell it change color differently when it contact with oil and water. So we will see where's the oil level, where's the water level, okay? And otherwise, other than the name, I think you should know that this tank will be kind of the tallest, the biggest one that you have, that you see. When there's a 2-3 tanks next to each other, the black one usually oil. Okay, because when oil spill, oil look black, and they don't have to. Nobody can